Okay, we'll do the numerical differentiation with Newton's forward method. So first we have to define the data set. Before that, I will define how many data points are there. I will take data from the video that I have shared so that you can see from here this video, and I am taking these values. So the values of x will be defined as a list of like 2 comma 2.2 comma 2.4 comma 2.6 comma 2.8 comma 3. Okay, this is the first data set, that is x in a list, and then we go to y values. Y values are y equal to 0.6932, okay, then 0.7885, then 0.8755, 0.9555, 1.0296, 1.0986. Okay, so these are the values that also we have to put as a list. So this should be a list. So that is the y value, and now what we had to do is that we had first find out what is first difference. So for that, let's consider y0 as our first difference, and we had to define it as empty list initially. Then we had to go for let's say for I in range of n minus 1. So we have to consider n minus 1 because it will go up to fifth in this only. Okay, so n minus 1, it is 6 minus 1, fifth indices, so up to fifth position it will go. So then we have to use colon, then we have to define some variable d equal to y of I plus 1. So this is the first value in the list y, second value in this y, or any value which is in the position I plus 1. So minus y of I. So what it will do, if it is I equal to 1, then it will go for y of 2 minus y of 1. So it is like that. So if it is the y, if the I value equal to 0, then it will go for y of 1 minus y of 0. So that is how it will calculate the differences. Then after that we had to go for y0. So y0 dot append. So this will append new values to the y0 list, empty list. So y0 d append d. Then if you want to calculate which is the first value, so let's say print y0 of 0, we get first value of the difference. So you can see 0.095299. So you can see from here 0.050953. So it is same. Okay, similarly we have all these values which is stored in y0 list now. Okay, now we had to go for next difference, that is, let's say y1. So y1 we had to put it as a list. Okay, this is a simplest way of doing. You can do it by using triple or any other method with all these loops, like loop in a loop, in a simple one single line or single operation. Now we are doing it in a different steps, so you can understand that much more easily. So let's consider the second difference as y1. Then we will go the same process for I in range. In this case it will be n minus 2 because we already having less value in y1, that is first difference, that is the total number of values will be 5. So it can go maximum n this in this will go up to 4. Okay, so we have to go like this. Then we have to do d equal to y. Now we have to do y0 of 5 plus 1, y0 of 5 plus 1, minus y0 of I. Okay, then go for what is that, y1. Y1 dot append, so it will append new values to the y1 list, that is t. Now it is okay. Now if you want to calculate the first value, for example, I can write print y1 of y1 of 0, right? y1 of 0, and if you calculate that, you get minus 0.08299. So that you can get from this also. So this is the method we will follow, and we will just do this. So now I have calculated for the third difference also. We can see from this y2 I have different. Here there is one mistake in for y2 calculation here, because I have given here y of I. So it is wrong. It should be y1 of I, and I calculate again here. So this is the third difference. So you can see y2 of 0 is equal to 0.00130. So you can see from here also. Okay, now we will go for the differentiation directly. Okay, so we have to write now what is the differentiation formula for this particular case when where p equal to 0. That means that we are considering the first value x0 equal to 2. So in that case p will become 0. So in that case we have to consider this equation. So you can see in that video we are considering for initial value x0 equal to 2, p equal to 0, then we will have a dy by dx differentiation of like this. And if you are considering any other values other than x0, that is the initial value, then you have to consider the p value also. Then you have to define what in program your p equal to x minus x0 by h. Okay, so now we will write what is this for this particular case only. Okay, so here I have considered h equal to 0.2, that is step size that you can take from this data, h equal to 0.2. And I have defined I equal to 0 because we are calculating for the first value, that differentiation, that is y dash at 2. Okay, so 2 is the first data point, so that is x0. So we are calculating at that point, so we are taking I equal to 0 in this case. Okay, so if you are calculating for the second value or third value or any other values, you have to take the I values accordingly. Okay, then we have written the differentiation equation here, that is the same as this. So this is 1 by h star y0 of I, so it will take first value. And if you are calculating any other value, you have to define what is the I position of that value. Okay, first or second. That how we are taking the values of the difference set or difference list accordingly. Okay, then if you print, then we will get 499 1499 41. That is the value that we will get. You can see from this video. Similarly, you can calculate by double dash also by using this equation. You have to give 1 by h square del square y square. So this is same. You have to put like for example d dy or something. Then you have to go for 1 by h square instead of 1 by h here, and star del square y0 minus del t. So this is the second difference minus third difference value. Then we will get the second differentiation by using Newton's method. Okay. So that's all about this. So it will be like this for second differentiation. So we have to go for 1 by h square star. We can also use the power syntax also here. Star y1 of this is the second difference value, first difference value. So you minus this like this in this case, and you will get minus 0.24. This is wrong because I have taken 1 by h star s. So it will take 1 by h first, then it will multiply with h. So this is wrong. So this is the right step. So this is second differentiation equation like this, and we will get minus 0.24 like this. So this is how we calculate the difference, numerical differentiation by using Newton's forward method. Okay, so you can use any other